Hi everyone. Today I'm going to demonstrate the Spectronic20D spectrophotometer. This spectrophotometer has a very good footprint for laboratory teaching purposes, and it has a variable wavelength that you could use. And if you just look at here, it has 340 to 599 filter, and also a 600 to 950 nanometers. It's really a very dependable, compact spectrophotometer, especially for undergraduate teaching. So to demonstrate and operate, this is a very easy operation that anyone can use as a student. It has knobs that are clearly marked. Here is the power on. If you just turn on the power right here, once you turn on the power on, the instrument needs to warm up so that it has a stable reading. Right now it is showing 510 nanometers. If you were to change the wavelengths, you just need to use this knob. As you see, you can use a variety of wavelengths. So for our demonstration purpose, today I will use a 510 nanometers wavelengths. So that would be adjusted by this. So right now it's 510 nanometers. I'll just stabilize it a little bit more. Once you have your wavelength set for your analysis, the next step is to make sure that there is no any transmitted light in a closed position. That means you need to adjust the transmittance to 0. Another important point, this instrument can be operated under a transmittance mode or absorbance. For example, if you want to absorbance, this is how you change it to an absorbance mode. So this is a mode selector button. This instrument is very sensitive in a transmittance mode, so I encourage you to use a transmittance measurement that can be easily converted to an absorbance by using a simple formula. So now in a closed position without no sample, no reference, this has to read a 0 transmittance, which is that. Right now it is 0 transmittance. Now the instrument is ready for a reference or a blank, and if we just use a deionized water as our reference, and the sample compartment is right here, you insert your test tube containing your deionized water for a blank. One thing I like to mention at this point, this instrument uses the thermoscientific half-inch diameter test tube. Those test tubes are specially made for optical purity, and they can accommodate samples more than 1 ml, 2 ml. Now you close the sample compartment, and as you see, 100% transmittance, which is consistent with what we expect. The transmittance, if it was not 100, you can change it by this. This is how you calibrate it to 100. Now 100% of the light is transmitted because it's a blank, and it is stable at 510 nanometers. Once we have that ready, we are ready for measuring our sample. I have a sample which is diluted from this red solution. That's why I have it at 510 nanometers. And this sample is a diluted one. I just clean up the test tube, put the sample back, and measure. As you see, that sample has a transmittance of 76%, which can easily be converted to an absorbance by using a simple formula. So if we just check other samples I have around here, if you have, this is a very concentrated one, so note only 1.0 is transmitted light. That's too concentrated. If I have another one here, this is actually about 50%. If you just use the logarithm of 100 over 50, around 50, you would get a 2. That log 2 would be about a 0.3 absorbance. So it's really a very dependable instrumentation, especially in teaching, and we are really delighted to send some of this instrumentation to a university in Ethiopia so that they can use in their teaching programs. Thank you for listening.